Welcome to my fourth class on complex variable 1. In this lecture video, I'll be discussing about type 1 problems, that is finding the derivative of analytic function. How to find the derivative of analytical function. So I'll be explaining the same in the working procedure. In the step 1, given w is equal to f of z is a complex variable. So here we supposed to replace z is equal to x plus iy or z is equal to r into e power I theta as a complex number to find the values of u and v. Second step, we supposed to find the partial derivatives in Cartesian form or polar form. Step number 3, we have to verify the CR equations in Cartesian form or polar form. If it is verified, we can say the function f of z is analytic. Step 4, we are supposed to find f dash of z or dw by dz. So the formula to find f dash of z is given by f dash of z is equal to ux plus ivx in Cartesian form, and f dash of z is equal to e power minus I theta ur plus ivr in polar form. Problem number 1, show that the function w is equal to z plus e power z is analytic and hence find dw by dz. So the first I'm going to take the equation w is equal to z plus e power z and I'm going to replace the complex number z is equal to x plus iy here. Since we know that w is a complex variable, I can replace w as u plus iv. So u plus iv is equal to, I got x plus e power x plus iy plus e power x plus iy. So I'm expanding this e power x plus iy as e power x into e power iy. So I got x plus iy plus e power x into e power iy. So it will become x plus iy plus e power x. The formula for e power y iy is cos y plus I sin y. So it will become e power x into cos y plus I sin y. Now taking the e power x term inside, I got the equation like x plus iy plus e power x cos y plus I into e power x sin y. Now I'm going to separate the terms of a real part one side. So I got x plus e power x cos y as a real part plus I times of y plus e power x sin y as an imaginary part. Now I'm going to equate both the equations. So I got u is equal to x plus e power x cos y, I got it, and v is equal to y plus e power x sin y, I got by comparing real and imaginary parts. I'll be calling this as equation number 1. Now I'm going to differentiate the equation number 1 with respect to x partially, treating y constant. Now differentiating u with respect to x partially, treating y constant, 1, I'll get dou u by dou x is equal to, x will become 1 plus e power x is e power x only, cos y is a constant as it is. Similarly, dou v by dou x will become, y will become 0, e power x is e power x itself, sin y is sin y. So I got the expression dou u by dou x is equal to 1 plus e power x cos y, dou v by dou x is equal to e power x sin y. Similarly, differentiating 1 with respect to y partially, treating x constant. So if I differentiate this equation with respect to y, I'll get dou u by dou y is equal to 0 plus e power x is a constant, cos y will become minus sin y, and dou v by dou y will become 1 plus e power x is e power x itself, sin y is cos y. So I got the expression dou u by dou y is minus e power x sin y, dou v by dou y is 1 plus e power x cos y. With this equation we can say that dou u by dou x will be equal to dou v by dou y, and dou v by dou x is equal to minus dou u by dou y. So this is nothing but CR equations. The CR equations get satisfied. We can say the function w is equal to z plus e power z is analytic. So once the function is analytic, now I am going to find the derivative f dash of z. Consider dw by dz is equal to ux plus ivx. So we have the value of ux as 1 plus e power x cos y plus I into vx is e power x sin y. Now from this equation, from the first and second term, I am taking e power x common factor. So I got 1 plus e power x into cos y plus I sin y, and this cos y plus I sin y is nothing but e power iy. So I got 1 plus e power x into e power iy. So since their bases are same, I can add the powers. So I got 1 plus e power x plus iy. So I got dw by dz is equal to 1 plus e power z. This is because of the complex number z is equal to x plus iy. One more example. Show that f of z is equal to cos hyperbolic z is analytic and hence find f dash of z. So first take the function f of z is equal to cos hyperbolic z. Since the complex variable f of z we can put in the form of u plus iv. So I got the equation u plus iv is equal to cos iz. This cos iz has been obtained from the formula because cos hyperbolic z can be replaced as cos iz. Now I'm going to replace the complex number z is equal to x plus iy in the Cartesian form. If I replace that value here, so I got the expression u plus iv is equal to cos of I into x plus iy. So now if I take I inside the bracket, I got the expression u plus iv is equal to cos ix minus minus y. Y minus in the sense I into I will become I square here and I square is minus 1. So I got cos of ix minus y. So now I am going to expand this equation by using cos of a minus b formula. It is given by cos a cos b minus plus sin a sin b. So I got the expression u plus iv is equal to cos ix cos y plus sin ix sin y. Now I can separate the real and imaginary parts. Since we know that cos ix we can replace as cos hyperbolic x and sin ix can be put as I into sin hyperbolic x. So I got the expression u plus iv is equal to cos hyperbolic x cos y plus I into sin hyperbolic x sin y. So I got u is equal to cos hyperbolic x cos y and v is equal to sin hyperbolic x sin y. Call this equation as equation number 1. In the first step, I will be differentiating u with respect to x and v with respect to x. In the next step, I will be differentiating u with respect to y and v with respect to y. Now, differentiating the equation number 1 with respect to x partially, treating y constant, I'll get dou u by dou x is equal to cos hyperbolic x is sin hyperbolic x cos y as it is. Similarly, dou v by dou x will become sin hyperbolic x is cos hyperbolic x sin y as it is. Now dou u by dou y, treating x constant, so cos hyperbolic x I am keeping as it is, cos y is minus sin y, dou v by dou y is keeping sin hyperbolic x as it is, sin y will become cos y. So on differentiating one with respect to x partially, treating y constant, I got ux is equal to sin hyperbolic x cos y and vx is equal to cos hyperbolic x sin y. And differentiating one with respect to y partially, treating x constant, I got uy is equal to minus cos hyperbolic x sin y and vy is equal to sin hyperbolic x cos y. So we can say that this ux is exactly equal to vi and this vx will be equal to minus uy. So hence dou u by dou x is equal to dou v by dou y we got and dou v by dou x is equal to minus dou u by dou y we got. It implies CR equations are satisfied. It implies w is equal to cos hyperbolic z is analytic. So now I am going to find the value of f dash of z. Okay, to find the value of f dash of z in the Cartesian form, the formula is f dash of z is equal to ux plus ivx. So the formula for ux is sin hyperbolic x cos y and vx is cos hyperbolic x sin y. So now I am going to expand this sin hyperbolic x as sin ix by I and cos hyperbolic x as cos ix. So I got the expression sin ix by I cos y plus I into cos ix sin y. 1 by I is nothing but minus I. So I got the expression minus I sin ix cos y plus I into cos ix sin y. So now from this entire expression I can take I common factor. Minus I common factor. I got minus I into sin ix cos y minus cos ix sin y. Now this can be written like sin a cos b minus cos a sin b. It will be equal to sin of a minus b. So I got minus I into sin of ix minus y. So from this expression, I am taking I common factor. I got minus I into sin I of x minus y by I, and this 1 by I is nothing but minus I again. So I got x plus iy here. So I got finally minus I sin I of x plus iy. This sin I of x plus iy is nothing but I sin hyperbolic iz. And I'm replacing x plus iy as z here. So I got minus I sin iz and sin iz is nothing but I sin hyperbolic z. I into I will become I square is minus 1. Already we have minus 1 here, so I got f dash of z is equal to sine hyperbolic z. Show that w is equal to log z is analytic where z is not equal to 0, and hence find dw by dz. So take the equation w is equal to log z. So here I am going to use the complex number in terms of polar form. Why? Because if I put z is equal to x plus iy, so I will get log of x plus iy. I can't expand the equation further and I'm unable to find the value of u and v here. So for that purpose, I'm using z is equal to r into e power I theta here. So I got the expression like u plus iv is equal to log of r into e power I theta. To expand this log of r into e power I theta, I'm going to use log of ab formula. Log of AB is nothing but log A plus log B. So I got U plus IV is equal to log R plus log e power I theta. And to expand this, I'm going to use log of x power n formula. Log of x power n is n log x. So it will become I theta into log E. And log E value will become 1. So I got only I theta here. So I got U plus IV is equal to log R plus I theta. And U is equal to log R and V is equal to theta. We got it. And I'll be calling this as equation number 1. So now I'll be differentiating the equation number 1 with respect to r and theta one time. So if I differentiate this equation number 1 with respect to r, the dou u by dou r will become 1 by r and dou v by dou r will become 0 since here no r variable is there. Similarly, if I differentiate u with respect to theta and v with respect to the theta, dou u by dou theta will become 0 because here no theta variable is there, and dou v by dou theta will become 1. So now differentiating 1 with respect to r partially, treating theta constant, I got ur is equal to 1 by r. R we can write this one as r ur is equal to 1. Similarly, vr is equal to 0. Differentiating 1 with respect to theta partially, treating r constant, I got u theta is equal to 0 and v theta is equal to 1. Now I can say that r ur is equal to v theta and r vr is equal to minus u theta. I can write it here. So that is r dou u by dou r is equal to dou v by dou theta and dou v by dou r is equal to minus dou u by dou theta. It implies CR equations are satisfied, that is w is equal to log z is analytic. So now I am going to find the f dash of z in terms of polar form. So f dash of z is given by e power minus I theta ur plus vr. Since already we know the value of ur and vr here, I can put ur is equal to 1 by r and vr is equal to 0. So I got the expression like e power minus I theta into 1 by r. I'm taking e power minus I theta to denominator. I got 1 by r e power I theta. So it will be equal to f dash of z is equal to 1 by z because r into e power I theta is nothing but z. Okay, in the next lecture video, we'll be discussing about the type 2 problem. The type 2 is an construction of analytical function by using Milnes-Thomson method. Thank you.